a lot. All right. So as you saw, as I just wrote that out, after today, which is and today is going to be about. I'm going to just try to conclude sort of generally the epidemiology, and I don't think I'll have time to introduce antibiotics. If I do, I will. Uh, so with antibiotics, basically next week, respiratory, skin, we'll try to get all of these in. These three at a minimum. Okay, maybe wounds and gas, at least some coverage of them, because I can always send you some additional information. So that's sort of the plan of attack, as it were, for now. And I just wanted, it's just easier if I write it down so you can see it as opposed to me having to get up. So without further ado, we begin. This is kind of where we left off and kind of where I started. Uh, Sort of generically talking about it. I'm going to look at both of these PowerPoints. That's 19 in Nestor, and then this one, which whatever there are 11 in Cowan. And so, really, epidemiology is fascinating. We have, for those of you who have Dr. Robbins, and many of you do, for AMP 2, he's an epidemiologist. Okay, that's where his PhD is located. So it's a very, very interesting area about the study and transmission, and it's constant. So you have it's a certain degree of detective work. It's looking at social aspects of things, interplay and interchanges that people have, various kinds of as well as other disease infestations, water supply, food supply, all of those things. There's so much to it. So by studying characteristics of it, effectively you're trying to isolate where this stuff came from. I have some interesting stuff to share with you about that. That is there. There's just so much of it. There's a misunderstanding. It just takes a lot of study to be able to find out what it was. I guess COVID was a little bit different because they were, for whatever reason, that got identified early on. When that transmission or the initiation of that occurred in China, like late in 2019, we start to hear more about it. Nevertheless, frequency and distribution, we're not going to analyze curves or anything like that. There's a wonderful exercise that I haven't done. I only ended up doing, last time I did microlabs probably over the summer. I won't be doing it now for a bit. But there's a wonderful exercise called the synthetic epidemic. Anybody do that yet? Okay. I'm going to try to encourage Doctors Hillwig and Dr. Dress to do that. I'm going to try to get them to do it because I love it. Okay. So lots and lots of, so it's not just looking at the organism, it's a variety of things that are there. So, and you have to look at all of these things to potentially look at the epidemiology. I mean, when you're looking at heart disease, is there a microbiome? Maybe there is, in some instances, but we're looking at patterns that are there. So this, they allude to Florence Nightingale. The other one that we could have looked at, and you'll see that in the Nestor PowerPoint, they talk about Semmelweis, who I talked about in the very first week. That whole thing with not cleaning your hands, the medical students versus the midwives delivering babies. So really, before germ theory, she was 1850s, 1860s, maybe more, maybe became more visible in and around the time of the Civil War as well. Filth contributing to disease, field hospitals, linens and towels, etc., etc. All of that type of stuff. So that's really what an epidemiologist does. They look at all of those types of things. So we're using, before it was strictly Koch's postulates. Now again they've changed. The other textbook, Nestor textbook, and I don't know if it's current or not, identifies what are called molecular postulates. They're looking for genetic impact or molecular biological impact as the source of what. So it could be an organism, but what makes that organism dangerous, if you will? Behaviors, all about it. So really, to me, it's fascinating because it's detective in nature. Okay. And so you're looking at the distribution, you're looking at the numbers, you're looking where everything is. We're trying to find out. That exercise in the lab is very simple. You put a chemical in little tubes of water, and we sort of force everybody to sort of, not everybody sharing with everybody else because everybody be contaminated, but selectively sharing little bits of water with your tube of water and identifying what was called the index patient. That's what it's all about. The index patient is what we look for is the first person to bring it into the community or where the epidemic started. If you saw, and it wasn't a great movie, that movie Contagion with Matt Damon. Some of you have seen that undoubtedly. That what happened there, the whole idea is they were tracing an index patient back to somewhere in Asia where the farm had contaminated, and all of a sudden everything came out. And farms are a frequent source of contamination. Originally, I thought it was that like farm market, that open air market in Wuhan. So all of these, and there's a lot of public health information associated with it. A lot of my colleagues who I graduated with many years ago went into it because one of my mentors was an MPH, Masters of Public Health. He did a lot of public health work in the city of Philadelphia. So we get to something I talked about before: reportable or notifiable diseases. That's because we got a shot at controlling them. They're either potentially very, very deadly and something that could spread crazily, or there's something that at least we have making an effort to control within our society to make it less problematic. I mean, the best way I can inform it to you is, and we're going to look at this disease a couple of times, particularly in genitourinary disease, the most famous of all the sexually transmitted diseases, syphilis. Okay? Maybe I told you, up until mid 80s, I'm going to tell you, in most states, you had to have a blood test before you got married. It has nothing to do with preventing the marriage. It had everything to do with finding if somebody had syphilis. Because that way they would blood test, see if you were a syphilis carrier, inform you. So at that point, that would allow them, and then they'd get in touch with you and track contacts and things like that in an effort to control the disease. That's why people got married in Vegas and in West Virginia, because those states did not have that factor, that whatever it was, 24 or 48 hours. So when my first wife and I got married in 1978, yeah, we both had the test. We passed. She informed me I would have been in significant trouble otherwise. But I digress. See, there's an opportunity for some of you to smile back there, but you're all asleep. Right? Just watch out. Okay. So what makes that and still is a notifiable disease. If anything, we've got a better handle on it now. They did away with that test over time because they got a better handle on it. And some diseases are reported voluntary, and there's all sorts of ways to track these. Look at the list. Now, some of these would be inherently obvious. Okay, gonorrhea, another sexually transmitted disease we're going to talk about. Diphtheria, we're all immunized with it. Botulism, certainly. Okay, chancroid, which we'll get to. Chlamydia infections. Chlamydia is the most common of all the sexually transmitted bacterial urinary tract infections. That's where we can still treat it and identify it and hope to reduce the possibility of it. Okay, Legionnaire's disease, we'll talk about that. Lyme disease, certainly. And so when a case like that comes into, let's say, the emergency room at a local hospital, they are obligated. And again, it's a legal matter. I say all about the licenses. If you're the one who's supposed to be reporting it, you better report it. Because if all of a sudden there's an outbreak and they trace back that so-and-so came to your place and you didn't report it, you're in big trouble. Those are the kinds of things you don't want against you. Now, I'll show you what's missing here. Let's see, HIV. Okay. I don't see human papillomavirus. Okay. The most common of all the sexually transmitted diseases. Not there. Another H, herpes. Not there. Why? Out of control. There's no hope. It's everywhere. You can't realistically control the spread of something that's got that. There's another one that we're going to get to called Trichomonas vaginalis. Okay, not trichinosis, which is a disease that was associated with pork consumption for a long time, though it's improved, but when you'll see Trichomonas vaginalis. Those are the three, not necessarily in any specific order, most common sexually transmitted diseases. They're out of control. Just saying. So a lot of these novel infections, that would be like bird flu or swine flu for influenza A, obviously all the COVID related stuff, these hemorrhagic fevers like Ebola, and many of them are probably very, very similar, etc. Just gives you an idea. So we look at certain things. We look at prevalence. Prevalence is a snapshot. It's a very good way to express it. The number of cases in a given population at any one time. Okay. Okay. So it doesn't account for whether they just got it or they're getting better from it. It's basically, do they have it in some way, shape, or form? So there's certain nuances with it. Prevalence of smoking in American adults in the U.S. is about now, whenever this was within the last 3 or 4 years, about 14%. I would dare say in the 50s, it was before the Surgeon General's report, which was in 1964, about when they officially put the thing on, the label on cigarettes and hazards for your health, and stopped advertising those things on TV, etc. It was probably 50%. My mom and daddy smoked 3 packs a day. Incidents, the number of new cases, very interesting number, because that gives you an idea if it's increasing in a designated time period, the number of total susceptible persons. Incidence of new tuberculosis cases in the United States in 2018, roughly when these numbers came from, about 4 or 5 years ago, 2.8 per 100,000. Years ago, we thought it was gone. We thought we had it completely under control. That suggests it's not quite so much under control. And again, that's one of those resurgent diseases I talked about early on in the course. So incidence is an interesting number. Is it coming out? Now, if we have an idea with these things about what they're supposed to be. So mortality rate, it's different than morbidity rates. So mortality, very straightforward, somebody who dies. Morbidity, someone who gets sick. It doesn't necessarily account, it implies significant illness. It doesn't have to be. Morbidity and mortality. So in a hospital, they have what's called a morbidity and mortality conference. They talk about this stuff among the doctors and the nurses on a monthly basis, and they go over, they have a rounds for that, basically a meeting about that stuff. Maybe you'll be involved with it. So overall death rate from infectious diseases has dropped, but the morbidity rates, we're seeing more people with them, even though our treatment is better. You can look at it that way. So you begin to look, measles cases reported by year from 20 to 20. Fascinating. Look how little. 2010, little uptick here, little uptick here. What happened? Vaccine laxity. No question about it. I think that was in and around the time we had that major case at Disneyland out in California. That's right. Number of lung injury cases reported as CDC as of November 3rd. And you begin to look at where we're starting to see larger numbers of problem. What does that mean? I don't know how to interpret it. So I wouldn't attempt to. But lung injury cases are significant infections. So does this have to do with industrial? Does this have to do with crowding? What does it have to do with? Why are certain areas in the green and why are some of those like that? I don't know. So we want to look, a lot of times when they're looking for an epidemic, you want to look from where it came from. So this is like looking for a contaminated water supply. Would be a classic example. So when they saw people getting sick in Michigan, even though it turned out to be a chemical contamination, still you're looking at seeing a reason behind those things, and you begin to trace it back. Okay, so a single infectious agent came from a single source. Everyone is infected as one. So it came directly from that point. Or is it one that is spread, whether it was just that one time they consumed something? Now the question is, why is it being propagated or spread? So if you have a foodborne illness, like we talked about with hepatitis A, okay, back in Chi-Chi's here in 2003, it started with an infectious agent that was communicable and sustained over a significant period of time, because before they realized it, it had spread to a lot of people, and people who were traveling, because it was right off the PA Turnpike in Beaver Falls. So it's, they hop off there, get something to eat. Next thing you know, big trouble. Who knows where they're going and in which direction they're going. A major thoroughfare to arguably as populated an area in the United States as there is, between New York, New Jersey, Ohio, Pennsylvania. Hello, that kind of thing that's going on. I'm not going to ask you, I'm not going to give you a scenario question and say, is this a point source or a propagated epidemic? I want you to just understand what the terminology is. I'm limiting the terminology in this. The ones I'm interested in are epidemics and pandemics and endemic, those kinds of things, major things. And I'll give you a list of those. And it should be what I provided for the last exam. Okay. Looking at these, and these are the kinds of things they look at these curves. I wouldn't endeavor to interpret them. This is what I was talking about, what I like to do in the lab. We look for the index patient. Who brought it in? How did it get there? Where was the contamination started? First case that brought the epidemic to the attention of the officials. So this is be an important definition. Endemic, and disease that exhibits a relative steady frequency over a considerable period of time in a particular area. The common cold is certainly endemic. If we weren't immunized, measles is endemic. Okay, there are certain things that are just constantly with us. There's no question about it. When they become an epidemic indicates that the prevalence of an endemic or even a sporadic, which is an occasional disease, all of a sudden goes past the expected numbers. So we know there's going to be, how do we know there's a flu epidemic? And nowadays we become so COVID centric that we kind of forgot that there's a thing called influenza, just don't hear about it as much. And frankly, I think that a lot of times we were getting false positives that were COVID. They certainly were during the initial period of that disease for, again, politicizing it. So what do I think happened? Okay, with regard to when something becomes an epidemic, with a flu epidemic, they knew they were going to have X number of cases per 1,000 or per 10,000. The reality is somebody with the flu doesn't always go to the hospital and have a test to see if they have the flu. So there's even a factor for that. They'll say if we have had 10 reported influenza cases at North Hills Pasadena Hospital, there's likely 100 or 1,000 in and around that area. There's a factor that they figure in based historically on what that is to determine or to ascertain how many actual cases and whether it qualifies now as an epidemic. It's effectively what it is. There's so much to that. There's a great deal of science to be able to analyze this. And the hardest thing, particularly with the sexually transmitted diseases years ago, when they would trace syphilis and gonorrhea, is public health workers would go to one person, you tested positive, tell me who your contacts were. How's that going? And then you got to go to the next, to all those contacts and say, who are your contacts? Are they protected or unprotected? And ladies and gentlemen, unprotected was for the longest time. Protected didn't become a real issue, which it didn't become a real thing until, I don't know, mid-'80s, after HIV/AIDS reared its ugly head. So it was a really interesting time. People just didn't use a lot because they weren't afraid of these diseases. Oh, if I get gonorrhea, I'll go and get it fixed up. So I did emergency room work. Not myself. I did mostly orthopedic emergency room stuff, but we did general stuff that was there. I can't even tell you how many people came in, every few weeks with the same diagnosis. You come in, get fixed up, see you a couple months later. Called it the carnal flu. Not realizing the amount of damage that potentially was being done. Just gives you an idea. So sporadic, occasional cases at irregular intervals. Maybe in the old days, before we had problems with vaccines, it would be, there's a measles case here and a measles case here. That'd be sporadic. It wasn't really a pattern. Versus epidemic, where we see a statistical, and it's all statistical, versus a pandemic goes across a major body of water. Read that as a continent. That's what makes it a pandemic. Like HIV/AIDS is, relatively speaking, controlled, if you will. It doesn't make it less of a pandemic because there are cases there. Then you start looking at the number. So again, starting to look at these from an epidemiologically. At the time of publication, when this came out, let's say this came out when COVID started, sometime I know the publication is probably 2022, but probably went to bed in publishers' terminology in 2020, probably 2021. They didn't have enough information statistically. So at that time, very communicable. And that's really what we have today. It's very communicable. It spreads, most of the times these variants spread easily. They're not nearly as severe as the initial case. That's a consistent pattern with a lot of diseases. As they particularly mutatable, as they mutate a lot. Sometimes you get oddball mutations, but most of the time spread more, not as bad. So, which is why in terms describe total number of persons afflicted prevalence. Okay, voila. So that's their little spin on this in the first, and I'll show you I'll flip through the. This is the Nestor one, which you'll see it on your blackboard, and you can go through it. The historical aspect was what's called puerperal fever or puerperal sepsis. It's a streptococcal infection. Same bad boy as strep pyogenes as a strep throat. Okay, but strep occupies a lot of spaces on our exterior. We find it in our mouth, we find it in our nose, we find it in a variety of different openings that are there, not the least of which are genitourinary areas that are there. And so that was Semmelweis observing it versus medical students versus midwives, saw a similar looking problem in somebody that he knew. And this is long before, a good 20 plus years before Pasteur's work, okay, and Koch's work for germ theory. And it turned out that quote unquote poison was actually the streptococcal and those things. You remember what happened to him when he said it was, medical students and doctors were messing with people. They ostracized him. It was the leading doctor in Vienna. And if you understand what the Austrian Empire, that was the palace. Mozart, Beethoven, those guys. They play for the emperor. So here it is, just looking at the studies, data about sources, etc. A lot of different eggs. So you have people with sociology, interacting patterns, psychology, how that impacts you. Some people don't care. They don't care if they're sick. They don't care if they know they have a problem. They're just going to do what they're going to do. Statistics, obviously. Okay. All of those types of things that are there. We talked about this before, communicable or contagious versus not. Okay. And again, direct or indirect. And those are important terms to remember for us. Direct physical contact or very, very close proximity when someone coughs or sneezes versus indirect, meaning that it came from a glass, it touched a fomite, some inanimate object, or change. It's like, take a scenario where somebody is working in a restaurant, they're sick, and their hand care was shoddy, or they probably shouldn't have been at work in the first place. They touch the food, you eat the food. That's not direct. That's indirect. Something came in between. It's not like you had direct contact with them, whether casual or intimate or otherwise. That is there. Non-communicable, can't spread them. Don't spread from host to host. So they're either from normal microbes or the environment. I have a whole little thing we'll get to with Legionnaire's disease. That's right, I was there. I know, it's just like a Forrest Gump quality to me at times. Okay, I was there. So, and I have a whole little spiel that we'll do when we do respiratory diseases. It turned out that Legionnaire's disease, which we now call Legionella pneumophilia because of it affecting the American Legion, and originally thought it was viral, and it was communicable, and it was a recurrence of the Spanish flu because the veterans. I'll give you the whole story. Why not? I'm talking anyway. We'll do it again because it's fun. Maybe we'll have 2 more people. I'm being very flip today. Are you awake? Happy to see you. But Sadie taking the day off again? Mm-hmm. Sadie taking the day off again?
I guess so.
I'm telling you. I know, you're not her keeper. You weren't here the other day.
I slept through my alarm.
Well, sure. It's okay.
Hey, I'm here now. That's all that matters.
Right. Perfect. The perfect response. That's okay. Moving on. So what happened was That was in 1976 in the Bicentennial in Philadelphia. It was the old Bellevue Stratford Hotel. I have no idea what name it is now. The Bellevue Stratford was a lot like if you've been our downtown, whatever that is, that's Ben Franklin, whatever that hotel is downtown. It's a very traditional, built in probably 1850s, 1870s, that before the last century. Very, very elegant. And what happened was they had a meeting of veterans for the bicentennial. Some from World War One. I mean, it was 1976. Someone could have been 80 years old, and that's what they thought happened. Is that it somehow, and when you have these, they have it's like a big room that they partition. So you have a big room that you meet in for presentations. They partition it for eating. They sit around at night and they drink and smoke and tell tall tales and all that type of stuff. What happened was older buildings are grandfathered in under code. In the old days, you had a crawl space that had ventilation, electrical pipes, water pipes, all of which have been added to. What happens, the dusty environment from these ventilation areas and leaky water pipes set up almost like an incubator for a particularly common bacteria that's everywhere basically and associated with water and dust and those kinds, and typically contaminates water supplies. And it became inhaled because it came through the ventilation system. They thought it was the flu. They sent the lead virologist for the Commonwealth of Pennsylvania, Dr. J. Satz, who was my virology instructor in 1975. Okay, a year later, they sent him to try to find the virus. He couldn't because it wasn't a virus; it was a bacteria. And that's when that's the way that worked. We used to have meetings in that building. It was a lovely old it was very, very proper, sort of reminiscent of like you watch British TV, the men's clubs, that type of thing. No women allowed. So rates of disease, more concerned with the rate than the number of cases because you can't address whether they're acute or subacute or convalescents. So you want to know the rates of the disease. So we want to do it over a unit of time. Ill in a population after exposure, that's how severe it is. And it may have a lot to do if you're dealing with an indigent population, an unvaccinated population, a poor population, the immune status. We look at that, particularly the number, the rate, and that's where the incident, that's a really good number, and the prevalence at any one time. But it impact on society, but includes all sorts of cases. And then the morbidity and mortality and how fatal it is. So Ebola, until we understood it a little better, had a remarkably high fatality rate, area of like 80 to 90%. Now it's probably with early treatment, maybe under 50%, still horrible, but certainly there. And then again, some of these types of endemic, constantly present, sporadic, epidemic, can be from an endemic disease. So something that is commonly there all of a sudden rears its ugly head. And the rest of this is not that tough. And then we talked about this, reservoirs, meaning where the entity is found that are there. So if it's just humans, and that's why we were so successful with smallpox, it's human to human. And once we had and we've had that immunization for a long time, it's the first one, back in roughly 1791 to 1793, there hasn't been a case from since 1977 that's been identified. Okay, so we assume it's gone. That's a long time now. It's a better part of 50 years. So human reservoirs, asymptomatic carriers we talked about. We'll get to this when we do sexually transmitted and urinary tract-based diseases. The biggest problem, and I disagree with this particular nugget here, because I think it's more symptomatic than that. The reality is that in men are more typically with sexually transmitted diseases are much more symptomatic than women. Women, it's silent until it gets into the tubes and the ovaries, and then it's big trouble. It's called PID, pelvic inflammatory disease, and it's not. We saw a ton of that when I was arrested because gonorrhea was epidemic, syphilis was epidemic, in the mid-70s all over. And we were basically a relatively indigent, poor population in the inner city of North Philadelphia. Just a tough area. Great pathology, but a tough area. I told you, it's like in the movies. If you had me for like AP1, I mean, car would drive up, they throw somebody on the sidewalk in front of the doors of the emergency room, and the car would drive off. They'd be bleeding, stabbed, shot. Didn't matter. It's crazy. Another one. Honest Indian? I shouldn't say that. Honest Native American. Right? Politically correct? Sorry. Yeah. Animal populations, harder to control. Plague, Hanta, rodents particularly. Again, zoonoses, again, depending on how much interchange you have with or how much you're exposed to those areas. But environmental is the hardest. No question. Water supplies, soil, things like that. And they talk about portal of entry and portal of exit. And very often they're the same, not always, but nearly always the same that are there. Again, we just talked about the vertical and horizontal transmission. This is the idea of direct and indirect. When we talk about pathology, a direct effect, and this is where a lot of students have a problem, I'm going into it. When something, typically an infection, the direct effect comes from bacteria, from toxins. Indirect typically means your immune response to it. Your body responds very agitatedly to some type of challenge. So most often with viruses, interesting enough, COVID being no exception, influenza being no, it's your immune system that's causing you all the problems, even though it's certainly a virus that's stimulated or caused your immune system to go crazy. It's a little bit, when we talk about disease transmission, it's different. So when I phrase questions, I talk about whether it's direct or indirect effects of the organism or the entity versus transmission. Direct transfer, okay, immediate transfer, handshake, intercourse, somebody in very, very close proximity to you. Okay. Droplets, that's when respiratory diseases. Okay. They generally fall to ground. So most of these are droplet transmission. You cough or sneeze, a la COVID, you're in close proximity. Once it falls to the ground, it's less of a problem to you. There's things that are airborne we will get to, like tuberculosis and Hanta. They're a little bit more problematic. Indirect, that's the airborne. Okay. So that's where in close proximity in tuberculosis, it stays in there. The longer you're in there, the greatest problem. You'll see if you're in nursing that there's a lot of precautions with active TB patients. There's certain kinds of personal protective equipment that are utilized there. They have exhaust fans pulling stuff out. That's sort of reverse isolation to try to pull that stuff out. It can trap in the filters relatively effectively. Interesting. Like there. So again, they remain suspended. Okay, so there's different things that are part of it. So there's a lot. That's that negative pressure in HEPA filters and ventilation system. I may have told you my middle one at age 1.5 was in the hospital, and we immediately, once we found out that the play group he was in at the local Y had a case of, and this is before the immunizations, of chicken pox. Okay, and this before he even had the chicken pox. We told him he was in the old children's hospital, which down where Presby is, in that same area. And he was on a floor having a GI workup because he had pretty significant food allergy problems. And they put him, because he was a clean case, on a clean floor next to the liver transplant, next to the major trauma cases. And all of a sudden he's infected. He's potentially infected. So all of a sudden he's in reverse isolation. I mean, they're taking this little baby around with masks and caps. And I couldn't leave the room other than to go to the bathroom. I stayed every night. I was there. The moral of the story, everyone, don't have children. So indirect. So when we talk about transmission, a fomite, anything could be it. Food, water, cross-contaminated stuff, municipal water systems. This is cryptosporidium. That's a part of a problem while we changed water treatment that's there. So vectors, and again, the distinction between mechanical and biological. The mechanical, as you can see here, didn't clean up after the dog, lands on the food, you're in trouble. Biological, blood meal, typical for mosquitoes, ticks, and things like that. So it becomes part of the biology of the vector. And the vector is just that, it's a conveyance. Bring it from point A to point B. And then all these other things. And then they talk about the virulence factor. I know I'm buzzing through, but you can read through this as easily as I can. Incubation. So this is the one I was telling you about, a salmonella infection, which is effectively typhoid fever. 10 to 14 day incubation allowed it to spread to at least 6 different countries. Okay. 10,000, they're on a ski vacation. All of a sudden, it's all over Europe. And I wanted to get to this note because I thought it was important, and that's herd immunity. Because we talk so much about it at COVID. Oh, we get herd immunity, we don't have to worry about it. Well, the reality is, the science is clear. Okay, you remember I told you about my oldest getting rotavirus down in San Antonio. Okay, they have herd immunity because it's been part of their population for a long time. We did not. It was our mistake. You know, and he could very well have succumbed to that, you know, at age 10 months. Okay, herd immunity protects non-immune individuals. Okay, in his case, very, very little. Shouldn't have been there in the first place. Antigenic variation, that's the problem with COVID. It's a rapidly mutating virus. And that's why that wouldn't have helped. And all these other health factors. Typically, it's very young and very old because of immune system. Less developed in the young, wanes in the old. And that's very true. I'm going to say this 63 times. If you're doing an intake, one of the questions we talked about the first week, when was your last tetanus shot? If you get somebody who's my age, they go, oh, it's had 2 years ago. Because they don't want another shot. I'm sick and tired of needles. Believe me, I'm in that group. I'm a little more transparent about it because I'm not stupid in that regard. Maybe I am. But because I got a cut from something dropping my foot 2 years ago. I knew I'd had a tetanus shot in 2019. I told him. He said, well, I'd like to give you another one. No, you don't. I said, I'll check with my doctor. I promise. Live long and prosper. Those kinds of things that are there. So what happens is with older folks, the next question is, oh, what happened? Did we give you that shot here? You can look at their records. Yeah. There's a very interesting TV show that ran for about 7 years called House. The premise of that show, House, if you're a devotee to that, is patients lie, and they lie all the time. They don't want to know. They don't want to know, oh, I was in the car, but, you know, it wasn't my wife or it wasn't my husband. You know, there's a lot of that going around. Trust me. Gender, we're going to talk about that with urinary tract. Different things with regard to certain types of behaviors. We'll look at those as well. Genetic background, particularly vis-a-vis lack of receptor on white blood cells that are there. This one has a lot to do with malaria. So there's different things genetically that are part of that. Again, I think the big problems that we have that are advantage to us, we have a very good water supply. Okay, most of us don't have overcrowding or poor sanitation, etc. The antibiotics are a big problem. And then they talk about all these studies. We're not going to talk about that. Okay. And again, this is the same thing. The CDC, if you're interested, go online, just go cdc.gov and look for the MMWR, Morbidity and Mortality Weekly Report. Basically tells you what's going on. Okay. And if you're going to, and this was part of what I did when I was doing that synthetic epidemic, I like to do so much. I had students take a virtual vacation. So pick an exotic location you want to go on that website, type in wherever you want to go. Our students are going down to Belize. The nursing students used to go to Nicaragua. Where are they going now? Ecuador, Colombia. Okay. Type that in, see what's going on there. That tells you what you should bring with you. Okay. What are the do's and don'ts? What are the problems? What immunizations do I need, if any? Okay. My stepdaughter went, first year of college, went to Costa Rica. The only thing I really advised her because it was so moist. And they said there's a greater potential exposure to things like E. coli, particularly like urinary tract infection, particularly in women. So she wrote a prescription along with Cipro, which is typically the drug of choice for that kind of infection most of the time. So didn't have to use it. So I would have the students do that. My definition for a virtual vacation was somewhere not Cleveland. You wouldn't want to pick an area that was similar climate or similar location. I happen to like Cleveland. I like Cleveland. It's the closest New York style kosher deli, not kosher really, but New York style kosher like deli. It's only 2 hours away. Very good corned beef. Corky and Lenny's. Just saying. And it's the same list that you saw before: public health, et cetera, absentee reports. Pretty straightforward. That's what, by the way, if you're looking, that's kind of what, that's when I talk about the smallpox eradication and things. And then we talked a bit about emergent diseases. MERS was the predecessor of COVID-19. SARS was the predecessor of MERS, all coronaviruses, et cetera. It's interesting. Okay, just to continue, I'll give you some insight into this. I mean, I probably told you about it when we talked a little bit about infections and severity. Contact lenses. And I think maybe I told you my sister, before she retired, was an executive for Bausch and Lomb on their ophthalmological pharmaceuticals. She was like a vice presidency level. And during her tenure at the end, she had to work 2 more years to restore her 401k, money wise, for her retirement. This happened when she was about 60. My sister now is, it's going to be 78. Yes. I get excited for things like that. Like for her 60th birthday, I got her a box of Depends. So she sent me a subscription to Modern Maturity. Nevertheless, what they had, the first and only time Bausch and Lomb had a contamination at a plant by people who became blind, because it was the number one, whatever, Boston something contact wetting solution. Top seller in the country. And it was a fungal infection at one of their plants in North Carolina. Nothing to do with where it was. She was on the team to get out in front of it, to try to deal with what they were trying to do on, meetings, how we're going to address this. They full responsibility and all that type of stuff. Okay, Lyme disease, big problem now because they build everywhere. Okay, and any of these you can look through. So war and civil unrest are fairly obvious. Refugee camps, various types of temperature things. We talked about the healthcare associated. These are interesting. We'll look at some of these, okay, that are there as time goes on, and I'll go through these laundry list rides because you can read through this as easily as I can read through it. So it's not, and these are when they talk about bioterrorism agents. Potentially they are there, and that's why we're always worried about smallpox and why they do keep some of the vaccine. It's the ultimate respiratorily spread, rapidly fatal, typically 3 or 4 days, that type of thing. Once it's like that are there. We're not even talking about botulism or things like that. So it's pretty interesting stuff that's there. Nearly done. I'll show you where we're going. We're kind of where we're going from this. And we'll get done a few minutes early anyway. The next chapter is the last chapter of this third exam unit. That's antimicrobials. Antimicrobials is the generic term. Antibiotics, antivirals, antifungals, antiprotozoans, they're all in there. That's where they are. All of these things. Where we find them, how do we make them? Are they occurring naturally? Testing methods you did. Did you do the antibiotic unit with the little discs? Okay, it's called the Kirby-Bauer method. They're still using it in the hospital every day. Okay. Therapeutic index, we're going to talk about that. It's an important measure. Safety margins, half-lives. Okay. So there's a fair amount of definitions. This really all didn't start until roughly it's not that people didn't know that certain things got you through infections. There was no treatment. Infections were deadly. When people got an infection, they were hoping they would survive until the advent of antibiotics. So a lot of these remedies with consuming moldy bread, which is where penicillin grows, was really types of things that were done prior to that. Aspirin, which comes from willow tree bark. We found that they used to make teas and infusions with that. So long before that kind of thing happened. It wasn't until there was a laboratory accident, for lack of a better way to describe it, that we discovered what penicillin was and what its effect was. And that occurred. It's credited around 1931. I think it actually occurred a little before that. We started manufacturing penicillin in and around 1940 and 1941. That's when it started. And it's if you want to look at things in medicine and in science, Pasteur, you could look at the development of the X-ray. You could look at Watson and Crick with DNA, the advent of antibiotics. Those are all things that have changed. At my age, I can look back and see what things are like. Just to give you an idea, and antibiotics would be one of them. We had very, very limited choices. When I was a kid, you know, God forbid you were allergic to penicillin, they almost had nothing left to treat you with. Type of thing. Still, and because in part of the allergies came from using it so constantly. There's so much to that. So we're going to look at these, and we're going to look at all of these types of categories and descriptions that are there. And I think to me, it's one of the really interesting units that we do. So I'll leave you all with that, and have a great weekend.